All right. Hello and welcome to this Smith's Interconnect webinar. My name is Katie and I will be your Global Spec moderator. Now I would like to introduce today's presenters and go over today's agenda. So with us today, we have Kevin DeFord. Kevin is the Defense, Space, and Aerospace Senior Product Commercial Manager. Also joining us today is Kyle Gobble. Kyle is the Product Line Manager for Defense, Space, and Aerospace Connectors. To read more about either of the presenters today, go ahead and look at that speaker bio window right next to the main presentation window. And now I would like to go over today's agenda. So today we're going to be focusing on the versatility of compact PCI connectors in space applications. So we're going to try to understand the environmental demands of outer space and the requirements of NASA S-311-P822. We're going to talk about some customer success stories within the Mars 2020 Perseverance Rover mission. We will find out the benefits and features of compact PCI connectors. We're going to be taking a sneak peek at our new press fit compact PCI connectors. And at the end, we're going to have our Q&A session. And with that, I'd like to pass it over to the presenters to get the webinar started today. So gentlemen, go right ahead.
Thank you, Katie. Hello, everyone, and welcome. I'm Kevin DeFord, Senior Product Commercial Manager at Smith's Interconnect, and today we will demonstrate the application of ruggedized connectors for space. We get to the next slide here. So the space environment is especially formidable when working with connectors, and today we will present a use case that involves backplane connectors that have been working on NASA's Mars Perseverance Rover for several years. Connectors in space environments that must endure severe shock and vibration and be immune to contact threading. They must be able to withstand extreme temperatures on Mars, which can drop to about minus 200 degrees Fahrenheit. As a point of comparison, the coldest recorded temperature on Earth is minus 128 recorded in Antarctica. Electrical contacts must make reliable connections and have a low and stable contact resistance to reduce power consumption. The material used in the insulators have to have low outgassing properties and be impervious to radiation hardening, as Mars radiation levels are 40 to 50 times higher than they are on Earth. Another important factor is how connectors are terminated to printed circuit boards, considering solder versus press fit terminations. All of these factors have to be considered when designing connectors for space applications. So Smith's Interconnect provides the Mars Perseverance Rover with high-performance K2A and K2B ruggedized compact PCI connectors, also known as cPCI. So addressing NASA's need for high reliability connector solution to meet mechanical, electrical, and environmental performance requirements. Rigorous testing was performed at the Jet Propulsion Laboratory for extreme environmental conditions, including thermal excursions, corrosive atmospheres, excessive shock and vibration, and then contact engagement and separation cycling, and other key NASA requirements. So Smith's Interconnect is proud to support the Mars Perseverance Rover with a connectivity solution specifically engineered and optimized to mitigate the effects of heat and shock and vibration, while maintaining exceptional levels of signal integrity. The K2 series of cPCI connectors is based on Smith's Interconnect unique Hypertac hyperboloid contact technology, renowned for its immunity to shock and vibration and threading. Testing to a high level space and aerospace test standards, the K2 series delivers high performance and mission critical applications such as military, land systems, shipboard, spacecraft, and defense applications. So the K2 cPCI series is qualified to NASA GSFC S311P822 and assigned NASA Goddard part numbers. It provides high speed signal integrity up to 3.125 gigabits per second, high-temp LCP insulators that meet NASA's outgassing requirements, key features to improve proper mating, and an integrated shield to minimize EMI and RFI leakage. Also, compatibility with reflow soldering processes, and then low insertion and extraction forces for reduced board strain and improved serviceability. So in 2021, cPCI was awarded Interconnect Product of the Year by the electronic industry. Now let's talk about the Mars Perseverance Rover. And let me say that the more I research the Perseverance, the more interesting it gets. So the Perseverance Rover was launched on July 30th, 2020 at about 8 a.m. on an Atlas V541 rocket from Cape Canaveral Air Force Base in Florida. The spacecraft departed Earth at a speed of about 24,600 miles per hour. The trip to Mars took about 7 months and traveled approximately 300 million miles. On February 18, 2021, NASA's Mars Perseverance Rover made its final descent to the red planet. It landed in a spot called Jezero Crater that is believed to have had water in it 350 million years ago. It is conceivable that microbial life could have once lived here. The mission to explore Jezero's crater on Mars for signs of ancient microbial life and collect rock samples, taking temperature readings, measure weathering conditions along the way. It has been designed to collect information to pave the way for future manned missions on Mars. The rover, nicknamed Percy, was designed to explore Mars for one Martian year, which is about 687 days on Earth. So Perseverance is NASA's most advanced rover ever designed to seek possible evidence of ancient Martian life. It includes instruments that can make microscopic scale maps of elements and organic molecules and rocks that could provide evidence that life once existed on Mars. Perseverance is also the first step in a series of missions that could bring samples back to Earth for deeper study, and is specifically tasked with the collection of the samples. One difference from Perseverance predecessor, the Curiosity rover, is that it can collect rock cores for study by scientists back on Earth. It has a larger turret at the end of the robot arm, which has the coring drill, 2 science instruments, a color camera for close-up surface inspection, which is also used to take selfies for engineering and health checkups. The workspace inside the rover body picks up and moves and places drill bits and has sample caching systems. The Perseverance also has 2 brains or computers located in the boxy body. The rover can switch between the 2 brains in case of a malfunction, so diagnostics can be performed on the other computer. The computer's processor is a radiation-hardened BAE RAD 750 operating at about 200 megahertz, 10 times the speed of its predecessor, and about the same speed as the first Apple computer, if you can believe that. The rover has multiple cameras and analytical systems on its hull and robot arm. The first one, Mastcam Z, has 2 mast-mounted cameras. They're about 2 millimeters high from the ground and are equipped with a zoom function that can take 3D pictures and videos of distant objects. The next is the SuperCam, which is also mounted on the mast and examines rocks and soils with a laser and spectrometers to see chemical materials that could be related to past life on Mars. It can determine mineral and chemical makeup of samples as small as the head of a pencil from more than 20 meters away. So, NASA loves their acronyms. So the next camera is Sherlock, which stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, is mounted on the robot arm, which provides similar capabilities as the SuperCam, but can extend from the rover and scan areas of Mars' surface. Another instrument that is mounted on the turret of the robot arm is the Pixel, which stands for Planetary Instrument for X-ray Lithochemistry. It's equipped with an X-ray spectrometer that can do elemental analysis at a microscopic scale. It can also take super close-up pictures of objects as small as a grain of salt. Well, Perseverance is also paving the way for future human existence on Mars. META, or Mars Environmental Dynamics Analyzer, measures wind speed and direction, temperature and humidity, and measures the amount and size of dust particles in the air. The rover is also equipped with a system that produces oxygen from the Mars atmosphere, which is rich in carbon dioxide, to test the way for future explorers to exist on Mars. So lastly, the rover is equipped with ground-penetrating radar to study features under the surface of Mars. Perseverance is also equipped with a drone named Ingenuity, which is mounted to the belly of the rover. So it made history by being the first aircraft to achieve powered, controlled flight on another planet. Designed to be a technology demonstration that would make no more than 5 test flights in 30 days, it has completed 72 flights to date. Unfortunately, the Ingenuity, so Ingenuity flying on Mars is the equivalent of a helicopter flying at about 100,000 feet on Earth. So it managed to fly around for about a minute, covering 200 feet. It's also powered by rechargeable lithium-ion batteries. So unfortunately, its final flight was on January 18th, 2024. So it's still upright in communication with ground controllers, but images sent to Earth indicate that one or more of its blades were damaged during landing. So, but Ingenuity far exceeded NASA's expectation and could be the key to future travel on the planet. The Perseverance, on the other hand, has been roving around Mars ever since. It landed, traversing approximately 16 miles, collecting soil and rock samples and testing atmospheric conditions. So on the lower right there, you can see the path that it's taken over those 16 miles. So let me hand it back to Katie for a poll question.
All right. Thank you so much for that. So we are going to run a polling question right now. So the question we're asking, who knows how long has the rover been operating on the surface? So we have a couple different options here. A is 2 years, B is 3 years, C is 4 years, and D is 5 years. So again, the question, who knows how long that rover's been operating on the surface? Again, you've got your 4 choices there. If everybody would like to log in their response, I'll leave this poll up on the screen for a moment so that everybody has a chance to answer. Again, options are 2 years, 3 years, 4 years, and 5 years. And we appreciate your participation. All right, guys, I'm going to leave it up on the screen for another couple seconds, get a couple more responses here. All right. Thank you, everybody that is popping your answers in. So I'm going to push us over to the results of this poll right now. Let's see what we got. All right. So we have a kind of almost an even split between 3 and 4. So I'll pass it back over to you, Kevin, if you want to talk about any of the results.
So, yeah, thank you, Katie. So the answer is 3 years, 2 months exactly. So as of May 10th, the rover has clocked 1,177 Earth days since its landing. So now let's talk a little bit more about the ruggedized cPCI connectors. So the award-winning connector is based on our hyperboloid technology, which has exceptional resistance to fretting corrosion caused by extreme shock and vibration. So it has been extensively tested to both NASA and military specifications. It delivers the highest performance in compact PCI connector format. It's been proven in many mission-critical applications such as military, space, and aerospace environments. So cPCI was designed to be a ruggedized backplane connector that meets the footprint requirements of PIC-EMG 2.0 and ERNI-style connectors. It utilizes Hypertac 0.4 millimeter hyperboloid female contacts in the backplane and uses mel pins and plug-in board. The hyperboloid contact has a series of gold-plated wires arranged in a basket that create a vortex that makes nearly 360 degrees of contact around the mating pin. And this is an important point that I think Kyle will elaborate on later. This gives the contact system superior immunity to fretting corrosion caused by micromotions, which allows it to withstand harsh environments where shock and vibration are an issue. So the contact system is reverse engineered compared to other backplane connectors, meaning that the backplane is a female contact rather than a male pin. The male pin is within the daughter card and is protected on all sides from stubbing or side load. We do offer some adapters to be able to mate with traditional commercial compact PCI connectors, but that's really not the focus today. So Smith's compact PCI connectors is the only backplane connector that is qualified to NASA's S311 PA22 specification. It's been awarded NASA Garter part numbers. The contact material, or the connector materials, are made from high-grade LCP and meets the outgassing requirements for spaceflight. So as mentioned earlier, the connector system has been put through many types of qualifications and adheres to the standards listed here. I'll give us that a second for anybody who wants to make notes. So in addition to cPCI's high reliability and immunity to shock and vibration, interchangeability and reverse gender features, it can deliver data rates up to 3.125 gigabits, which surpasses the requirements of the Perseverance 200 megahertz processing speed. So there are also keying options available that can ensure proper mating of the plug-in card to the backplane system. Finally, a shield is located on the back of the connector to prevent noise from outside electromagnetic interference and radiation. So the form factor for cPCI is based on the Eurocard industry, which defines the card size for a plug-in board. So a 3U card is 100 millimeters by 160 millimeters wide, and the 6U card is 233 millimeters by 160 millimeters long, which are both defined in the PIC MG 2.0. So in a high reliability environment, cPCI offers the durability to withstand shock and vibration with a long life in the field. So the connector is designed to perform to 100 ohm impedance systems performing at 3.125 gigabits, and the plug-in incorporates a shield for improved shielding effectiveness. The backplane utilizes award-winning hyperboloid contact, which provides 360 wiping action and stable electrical contact. So now I'm going to hand it back to Katie for another poll question.
All right. Thank you, Kevin. So next polling question, everyone. So it's up on the screen for you right now. Who here has used Smith's Interconnect products in space? So 3 different options here for your answers. I'm a current user. I've used products in the past. And third one here, not yet, but you're convincing me. So if you could pop your answer into the poll, that would be great. I will leave it up on the screen again for a couple seconds just so that everybody can start to respond. And question again, who here has used Smith's Interconnect products in space? And 3 options, I'm a current user, I've used products in the past, and not yet, but you're convincing me. So again, for the audience, feel free to answer. I will leave it up on the screen for a couple more seconds. All right, thank you for everybody who is participating. I'm going to pop up the results in this time. All right, and here's our results slide. Gentlemen, if you want to talk about that.
Yeah, thanks, Katie. I'll take over from here. Well, it looks like we are beginning to convince some of the attendees on the call today. That's good. So I'm going to start digging into the history of compact PCI space. Before that, here's a brief overview of Smith's Interconnect's long heritage of designing compact and reliable space products. Our applications include launchers, satellites, manned space flight, and ground systems. Our solutions have been designed from scratch to include materials and control processes for minimum mission lifetimes of 15 to 20 years. So our KMB, KNC, and KND, one of our PCB connector series, which is qualified to the ISA 3401 specification, first on this list. Currently, we've launched the NXS series, which is a system that can withstand data rates up to 50 gigabits per second per bay, including extreme levels of vibration, shock, and climatic testing above 2100 Gs. We have our KVPX series, which meets VITA 78 space VPX requirements and is qualified to NASA EEE INST 002 Level 1. Our spaceable radiation-resistant optical transceivers can deliver a bandwidth in excess of 300 gigabits per second. And finally, our thermopads, which are also used on the Perseverance Rover. So history of compact PCI for space. So compact PCI, which is often called cPCI for short, is a modular computer bus introduced in 1995. These computer architectures combine a Eurocard type connector and PCI signaling and protocols. Even though compact PCI was originally introduced in the industrial setting, its rugged architecture, low power consumption, and backplane I/O architecture found it a home in the defense industry. Unlike the original Eurocard solutions, such as VME, which uses connectors with a 0.1 inch or 2.54 millimeter pin spacing, compact PCI cards use metric connectors with a 2 millimeter pin spacing, which are designed to the IEC 1076 standard. The NASA S311P refers to a series of specifications used by NASA for various components and applications. The specification covers the procurement requirements for electronic circuits in NASA Goddard Space Flight Center space systems that require extreme durability. In 2007, NASA named Smith's compact PCI style connectors utilizing the Hypertac wire basket contact system for their S311P-822 high reliability 2 millimeter compact PCI specification. So here's a comparison between the commercial compact PCI connector solution and S311 versions of those connectors. The commercial compact PCI connector was designed for use in the telecommunication and data communication industries, where temperatures are fairly stable and shock and vibration are far less than in spacecraft launches. In these industrial applications, it's common practice to swap out and upgrade cards on a periodic basis. This material was not selected for its robustness for harsh environments, and in particular, stability under soldering temperatures. Since soldering was not part of the original design for this connector, even though these connectors are press fit, NASA and other contractors may choose to go back and solder fill vias for increased durability of that connection. These commercial connectors use bifurcated socket tines, which are sometimes called blades, which look like tuning forks. These types of contacts are susceptible to spreading during harsh shock and vibration and temperature cycles. The S311 compact PCI connector, however, has been designed with solder tails in both gold and 63, 37, and lead finishes. So that's 63 and 37%. The insulator is designed to withstand the temperatures of soldering without cracking and meets NASA's outgassing requirements. The requirement requires a maximum total loss, mass loss of 1% and 0.1% collected volatile condensable materials. The pin and hyperboloid sockets do not spread and are immune to fretting in the harshest environmental conditions. And finally, as Kevin mentioned earlier, the S311 compact PCI connector is reverse gendered in the commercial version, with pins on the daughter card side and sockets within the backplane. So what is EEE INST-002? Well, to answer that, we must understand its purpose. So this is a technical specification written by NASA Goddard Space Flight Center with the purpose of instructing designers and component vendors on the baseline criteria for selection, screening, qualification, and derating electrical, electronic, and electromagnetic parts. Hence the EEE designation at the beginning of the specification. This is used by the NASA Goddard Space Flight Center on selecting components for space flight programs. This document provides instructions for meeting 3 reliability levels of part requirements based on the mission needs. Of these levels of part reliability, confidence decreases by reliability level. Level 1 being the highest reliability, and level 3 being the lowest. Level 1 parts, sometimes called grade 1 synonymously, should be selected and processed to this level for missions requiring the highest reliability and the lowest level of risk. The typical mission duration for level 1 programs is 5 years or more. Level 2 parts should be selected and processed to this level for missions with a low to moderate risk, balancing the cost constraints and mission objectives. The typical mission duration for level 2 programs varies from 1 to 5 years. And level 3 parts are intended for mission applications where use of high-risk parts is acceptable. The typical mission duration for level 3 programs is less than 1 to 2 years. So how does this relate, or how does compact PCI relate to EEE INST-002? So why is EEE INST-002 relevant to our compact PCI product? Well, for starters, our S311 compact PCI connectors meet level 1 mission requirements. In Addendum 1 of NASA's guidelines for electronic part selection, NASA added a list of prohibited connectors. This includes connectors with compliant pin press hit terminations. I pulled this excerpt from Addendum 1, which lists all the prohibited connector technologies. In addition to calling out the compliant pin press hit terminations, it explicitly calls commercial style compact PCI connectors and other 2.0 millimeter hard metric connectors with bifurcated or tuning fork type female contacts as being prohibited. Also included in the excerpt are Eurocard type, VME, the various mil-spec tuning fork connectors, and all other high-density blade and fork connector systems. So the Smith's connectors K2A and K2B, which is our standard catalog version, and the 311P 822s, compact PCI series, is our NASA qualified and tested catalog version, addresses the market need for a high reliability connection solution which meets the mechanical footprint and electrical performance of the compact PCI specification. Thanks to our product's footprint compatibility with commercial compact PCI solutions, there's an easy path to upgrade current ground-based systems for the vigorous requirements of spaceflight. Our 311 connectors are currently the only compact PCI connectors approved by NASA for spaceflight. So what's next? The EEE INST-002 design guideline does not govern programs for commercial spacecraft, foreign spacecraft, or the United States DoD. These represent significant customers, especially in the ever-growing commercial space market. We are seeing more and more successful use of connectors with compliant termination by these non-government programs. One good example is VITA-78 space VPX architectures, which use press-fit VPX connectors, such as our KVPX connector system. This effect is most likely due to a few reasons. Printed circuit boards are continuously getting thicker and therefore stiffer, reducing localized vibration at the connector interfaces. In addition to this, engineers are getting better at designing these cards. The increase of cheap, tiny, short life satellites used in LEO constellations having a lifespan of 5 years and not the typical 5 to 7 years of MEO and 15 to 20 years of GEO is another data point. Another interesting fact on this topic is currently in space, there are 15,900 objects in LEO, 1,488 objects in MEO, 2,931 objects in GEO, and nearly 3/4 or 72% of these active satellites fall into the small satellite category. This domination of small satellites is relatively recent. Only 34% of satellite launches in the 1990s fell into the small sat category, and by the 2020s, small satellites comprised 94% of all satellite launches. So therefore, we've received many requests for and currently plan to launch a press fit version of our compact PCI connector system at the end of this month. Just to reiterate, even though the connector includes press fit terminations like its commercial counterpart, this product will still include our hyperboloid sockets like our NASA S311 qualified versions. The press fit version will have the same performance as our NASA S311 qualified product, except for the press fit installation. The data rates of up to 3.125 gigabits per second and the same immunity to shock and vibration you can expect out of any of our connector systems, including a hyperboloid contact. We expect this to be a popular addition to our product portfolio, targeting customers looking for a solution capable of withstanding harsh environmental conditions with the easy installation provided by the press fit termination. And with that, I'll hand it back to Katie for Q&A.
All right, Kyle, thank you so much for that part of your presentation. Kevin, thank you for yours as well. So for our audience members, we are going to move into taking a couple questions at this time. So I'm just going to start with this first one. This person is asking, what are the gold thicknesses on your contacts?
So I can take that one. So for the hyperboloid socket, the wires inside the basket that make the electrical contact to the male pin are plated with 50 microinches of type 2 hard gold. So all the other surfaces, which are not functional to the performance of the contact, are plated with a flash of gold on the backplane side. So the contact area of the male pin is selectively plated with 50 microinches of type 2 gold. And I think Kyle mentioned earlier that the rest of the socket tails would have more of a flash of gold on them. So that's for for soldering applications. You don't want too much gold in there for gold embrittlement. So and then we also offer the 6337 10 lead finish on the contact tails.
All right, thank you so much for that answer. All right, gentlemen, next one here. Are the solder tail and press fit connectors mechanically interchangeable?
Yeah, I can take that one. So the solder tail and press fit connectors are not mechanically interchangeable, just due to them having different footprint via sizes. The press fit termination vias are optimized for the installation forces of the press fit itself. And however, a customer may choose to adopt the press fit PCB footprint and solder fill the vias to use the solder termination. Essentially, the board would be able to use both styles of connector that way.
All right, thank you for that answer. We do have a couple more questions in the queue. If you do have a question for us, feel free to enter it into that window now and click submit. All right, gentlemen, next one here. Are the press fit connectors compliant to the S-311-P822 specification?
You want me to get that one, Kyle, or do you have that one? So I can take it. So
sorry, I was on mute.
No, that's fine. No,
Go ahead.
So the press fit compact PCI product will, have the same, pin and socket contacts. Its compliant pin terminations will make it non-compliant for the S311 PA22 spec, but it will be intermatable. So with S311, so they are intermatable with each other.
Thank you for that answer. So we have a couple more minutes for questions. If you have any, feel free to enter them now. Kyle and Kevin, I think we're going to take one more if that works for you guys. And then anyone that has any other questions, feel free to enter and we'll get back to you following today. Gentlemen, this last one here, are your cPCI connectors intermatable with the industry standard cPCI connectors?
So so again, want to point out that the back plane on the compact PCI is reverse gender. We do make adapters that can go either way. They can go from the daughter card to the back plane if you were using a commercial back plane connector. So we have an adapter for that, or it can go the other way.
All right. Thank you so much for that answer. And we do have one more question that just popped up into our queue here. So let's grab that one before we wrap things up today. This person is asking, why are press fit terminations different between the two connectors?
Yeah. So if I understand the question correctly, I think if I jump back to the previous slide, I think the question is around the different shape of them and essentially why they look different. It's just because they're two different manufacturing processes, one being essentially stamped into a wafer format of how we build the daughter card side, and then how we build our sockets into a turning machine version of the tail. So it's just a manufacturing decision of why they would look different. And obviously size requirements based on one side being a socket and one side being essentially a wafer pin version.
All right. Thank you so much, Kyle, for that last answer. So we are going to start to wrap the webinar up right now. So I wanted to say a huge thank you to Kyle and Kevin for such a great presentation and for being here with us today. So gentlemen, thank you so much.
Thanks, Katie. Thanks to all the attendees too as well for attending today. Really appreciate it.
Thanks, Katie. Thank you, everyone.
All right. Thank you both so much. And a huge thank you to our audience members for being part of this webinar event. Take care, and we will speak with all of you soon.